Okay, we're going to look at solving linear systems through elimination. So a linear system is the concept of one or more lines. I should say two or more lines. We quickly take a look at this. This one's set up very nicely. But the first thing I should actually try to do is kind of prove that's a linear system. I can isolate for y and put it into slope y-intercept form. It won't help me with elimination, but it does help me prove that this is a linear system. Sorry, give me one second. So in order to do that, for elimination, what we're going to do instead, we'll go back actually when we go to solve it or prove it by substitution. We will go back and prove it's linear. For elimination, let's just go on a limb and go. Let's assume it's a linear system or a linear equation, two sets of them. We need to use a method called elimination. For elimination to work, we actually want to line up our variables and our constants. It just so happens in this question that's all done for us. Our x variables, so the coefficients and the variable, are lined up on top of each other. The y variables are lined up vertically, and so are the constant terms. It doesn't matter what side of the equal sign they're on, just as long as they all vertically line up. The reason we do that is we're essentially going to make like our classic addition or subtraction question out of this. Our goal here is to eliminate one of the terms. So to eliminate one of the terms, we essentially need the coefficients to be the same. So when we look at this, they're all actually relatively simple to work with. Oh, good, it works out. For a second, I thought I made an error. I'm going to start with x. We're going to use this x coefficient. We're going to try to eliminate this value, okay? In order to do so, I need it to be the same coefficient as this. So what that means is I need to take equation 1, and I need to make sure its coefficient is also 6. In order to do so, I multiply it by 2. But when you do that, you actually have to multiply every term in equation 1 by 2. So think of it like equation 1 is being multiplied by 2. So the new equation 1 will read 6x plus 4y is equal to 36. We'll keep the original equation 2, 6x minus 4y. Oh, good, that'll work out. Equals 12. And we've set them up vertically. Now we need to eliminate. So here's the tricky part. This coefficient is 6. They're both positive. We need to use either the operation of addition or subtraction to eliminate it. Most people are most comfortable with addition. So if we were to say, hey, let's add these together, 6x plus 6x, we need to make it so it equals 0. 6 plus 6 gives us 12. So addition wouldn't be the correct operation to use here. So instead, what we want to do is we want to turn this into a subtraction question, okay? We're going to subtract here. So when we do that, 6x minus 6x would actually give us 0x. And that's the goal. The concept of elimination is to eliminate one of the variables. Carrying that along, positive 4y minus negative 4y is actually the same as 4y plus 4y. So this actually ends up being positive, and I'll put it in black here, positive 8y. And then 36 subtract 12 will actually give us 24. So once we have that, we do go back to some of our substitution stuff, or really it's just our algebra. At 0x, or 0 times anything, is 0 itself. So we end up with just 8y is equal to 24. And then we have to isolate for that y. In order to do so, we divide both sides by 8. And we end up with y is equal to 3. Now, once you get to this step, it's really common to actually revert back to substitution. Oops. And the reason being is because from here, it's actually really easy to use substitution. We know that y is equal to 3, so we literally just plug 3 in. But instead, since we're practicing elimination, I'm going to use elimination to, instead of getting rid of the x variable, we're going to get rid of the y variable instead. So we're going to set the whole thing up again, but this time we're going to get rid of the other variable. So I'm going to move it over here. The first equation is still 3x plus 2y equals 18. And the second equation is 6x minus 4y is equal to 12. We want to set them up vertically, which we've done, but we need to make sure the coefficients are the same. Same concept here. I'm actually going to be multiplying the very first equation by 2 again. I need it to be equal to 4. So again, we're going to multiply each of these terms by 2. We already know what that becomes. When we go to rewrite it again, 6x plus 4y equals 36. Okay, and we just happen to be multiplying by 2 in both situations. That does not always work out. This is like a rare instance. We might have to, if this had been 9 or 10, let's say 10 is a better value, we would have had to be multiplying by 5. Okay? We'll bring down the second one. 6x minus 4y is equal to 12. Set them up vertically. But just like before, we need to eliminate the 4's. In this case, we have a positive and a negative 4. It turns out that addition is what will actually get rid of these values. So when we deal with the addition with the 6x, that gives us 12x. That's fine. Positive 4y plus negative 4y is essentially 4y minus 4y, which gives us, and we can say positive or negative, but it's 0y. We've eliminated the y. And then here when we add them up, we get 48. We go back to our algebra again. The 0y disappears. It doesn't have any value. 12x is equal to 48. We divide both sides by 12. And we end up with x is equal to 4. So the final answer here, if we write it as a coordinate, x always comes before y there. We write x then y. It would be 4, 3 would be the solution to this linear system. Now, before we end it there, we need to prove this through substitution. Now, technically, I could start at the very beginning and use my whole substituting one entire equation in for the other. But substitution really just means plugging in a value. We have two values here. We say x is equal to 4 and y is equal to 3. I'm going to take the two original equations. So the first one was 3x plus 2y is equal to 18. And the second equation was 6x minus 4y equals 12. I'm going to zoom back in. Oh, zoomed in a little too much, I guess. I can use substitution to prove this. I'm going to substitute 4 in for the x value, and I'm going to substitute 3 in for the y value. And then we're going to see, is this true? 3 times 4 plus 2 times 3 is equal to 12. Is this true? 3 times 4 is 12. 2 times 3 is 6. Is 12 plus 6 equal to 18? Yeah, 18 is equal to 18. That checked out. So there's a proof. Let's do the same over here. It should also work in this situation. We can plug in 4 for x and 3 for y. We end up with 6 times 4, subtract 4 times 3 is equal to 12. Is this true? 6 times 4 is 24. 4 times 3 is 12. Is 24 minus 12 equal to 12? Yeah, 12 is equal to 12. So we kind of use substitution, not in its full sense where we substituted entire values, but in its partial sense where we substituted our final values to prove our elimination. That substitution at the end isn't necessary, but it's a nice way to check and show that there's multiple methods for solving a linear system.